All right, everyone. We've got around about 30 people so far, which is fantastic. And already I can see from a range of countries. I'll ask one more time that if you can, we would love you to turn on your camera so we can see your faces. And if you can keep yourself muted for now, that would be brilliant. We'll try and do any interaction through the chat if you need anything. Now, I know we do have some familiar faces coming back for workshop 2, which is fantastic to see, but we've also got some new people joining us for the first time. So I will reiterate that we record these sessions. We'll make them available on YouTube for anyone that can't come along, but we'll also be using those recordings to improve our offerings and also to conduct research on our practices and be able to turn the mirror back on ourselves. We won't make any of you identifiable in the data. And if you would like to opt out and not be part of being filmed or anything like that, then you can send me an email and let me know, or let me know now. And also, I'm going to put a link into the chat now for anyone that's interested to find out more about the research that we're doing or read our ethics paperwork. So that's in the chat now. Now, if no one, I'm seeing that some people, I do this every time, someone messages and says they can't hear me, and then I try and talk to them about why they might not be able to hear me, which doesn't work because they can't hear me. So I'm just going to put something in the chat. If you can't hear me, whenever you tune into these calls, always good to make sure that the volume on your computer's turned on and you clicked yes to allow connecting to audio. And lots of you getting back in touch saying, excellent, I'm loud and clear. That's good. I'm often loud and more regularly not clear. So that's a good thing. I am not audible from Anam Ansari. Okay, well, again, if you can't hear me, check that the computer audio is on and turned up. And also, you might want to click on, again, me telling you this probably isn't going to help, but you might want to click on the mute icon. Great. So if anyone's having trouble, hopefully now they've got the information they need. I'm going to ask Jesse Chambers to turn on his camera now so you can see his face. And also, Jesse, if you could flick to the next slide for me really quickly. Okay, so we're going to do this at the start of every session. I'm going to reintroduce myself or introduce myself for new people. My name is Joe Duggan. I work at the Australian National Centre for the Public Awareness of Science at the Australian National University. And I am part of or a member of Circus International. And we are a program that work all over the world and seek to learn from various groups that we work with and also try and share some of our knowledge around STEM learning and informal or formal education. This is number 2 in a series of workshops that are proudly supported by UNESCO Jakarta. And we're going to be exploring a range of different really interesting STEM topics and pedagogies, ways of teaching, modes of teaching, platforms of teaching. Like I already said, I will be sending an email to everyone that has attended that will have a whole bunch of links in it. It will give them the chance to be able to watch this recording back. It will give them the chance to be able to join either of our Facebook groups, the closed one that is just for participants, people that we work with directly, and the open Facebook group where everyone can join and you can see what we are up to. Also, everyone, I will say that at the end of this workshop, in that email that I sent you, there will be a survey. And it's a very short, very simple survey. But some of you that have already participated in our first workshop will see that if you complete that survey, that is where you get your certificate of participation with all the appropriate branding, logos, and notifications on there. So definitely worth participating in that survey. All right, ladies and gentlemen, that's a lot of talking from me. I'm going to stop talking now, but the last thing I'm going to do is introduce Jesse Chambers. Jesse is a STEM educator with experience across formal and informal learning settings. He currently works as a program coordinator for Gateways, and I'll let him talk about that a little bit more. Jesse has also participated in the Australian Science Circus. He is an extremely experienced STEM communicator and teaching professional. And he's going to cover a whole bunch of very interesting elements of inquiry learning. Jesse, the floor is yours.
Thank you so much, Joe. Wow, hopefully I can live up to that introduction. Like you mentioned, I work for a company called Gateways, and I develop science and STEM-related education programs for high ability students. So providing opportunities for them to receive extension. But something that I'm really, really passionate about is inquiry-based STEM learning. And that's because inquiry and STEM really do go hand in hand. So inquiry being asking questions, or your students asking questions, and through experiences trying to find answers for those questions. And we can make that relevant through STEM learning. So I know that last time you explored relevance, and STEM is an excellent way that we can bring in some relevance. But I'd love to know what you think of when you hear the word STEM. So I'm just going to pop in the chat code. And I'd love you to go to menti.com, www.menti.com, and pop in that code and fill in 3 words that you think of when you hear the word STEM. So there's been a bit of research done on what teachers think of when they hear STEM. And I know what I think about STEM, but I'd love to hear what you think about STEM and maybe your experiences with it. I'm also going to share the screen so we can see the responses that, that I've produced when we pop those words in.
I'll just say, Jesse, if anyone's on a phone or a laptop and struggling with both, that's fine, but also you can very easily open up a new web browser and go to menti.com, and you can still enter that link and you should still be able to see it. So don't be afraid to have a try at it.
Yeah, and alternatively, if you're unable to access that link for whatever reason, pop it in the chat too. And that way we'll be able to see your responses in the chat. And don't be afraid to include the good, the bad, and the everything in between. It doesn't all have to be positive. I certainly know that when I first dived into STEM, I thought it was resource intensive. But hopefully through some of the activities that we do today, we'll find that you can actually do quite a few STEM subjects, or STEM activities rather, with resources that you've got around the home. So collaborative learning, absolutely. Design process, I can see someone's popped design process here, and project-based learning. These are all things that we can do when we're using STEM. I'm just going to jump back over to the other screen in a moment, or to the presentation, because the thing that I think of when I hear STEM is the word integrated. So thanks for sharing your responses for that one. If you're unable to access it, then you're more than welcome to pop your answers in the chat. But traditionally, we've taught science, technology, engineering, and maths in this sort of siloed way of thinking, where we separate them out and treat them as individual subjects. But we can conceptualize STEM in a number of different ways. Now, on the left is the way that I used to try and aim for STEM. And that was to include an equal amount of science, tech, engineering, and maths in every activity that I did with my students. But in reality, some of the activities that you're going to do will have different focuses. And so STEM's not so much a subject, but a way of integrating these different areas and these knowledges and skills so that students can develop thinking skills, and then they can develop ways of tackling problems like they would through inquiry-based learning, which is more like they would experience in the real world. So in the activities that we do today, you may notice that some of them have a stronger science focus, or they may have a stronger engineering focus, whereas others may have a smaller maths focus and vice versa, and that's okay. The important thing is not to forget that the E or the M exist, or the S exist, or the T exist. They're always there, and we're trying to include them. But I thought we could dive straight into talking about some different types of inquiry that lend themselves to STEM learning. Now, these are just 4 ways that we can conceptualize inquiry-based learning. And these 4 levels, which were developed by Bunke and Bell in 2008, they're only 4 ways. They're not an exhaustive list, and there are other ways you can conceptualize them. But we can sort of conceptualize them in terms of how student-centered the inquiry is versus how much control the teacher has. So beginning with confirmation inquiry, we're going to work our way through these different types of inquiry to explore how we can structure them and how we can set them up so that your students can answer questions. So you can see that the level of teacher control with confirmation inquiry is quite high compared to open inquiry, where the students have more responsibility over designing an investigation that they might be exploring. Now, some of them may have additional steps in between, but in general, as we're moving across from confirmation inquiry to open inquiry, we're removing some scaffolds that we may put in place to support students as they're developing their inquiry skills for answering those questions. And I thought we could start with confirmation inquiry. And in this instance, the learner is given the question, they're given the procedure, and quite often the outcome is known. So it's confirming something that you may have already taught. If you've got the materials available with you, Joe, I'm just going to switch on my other camera.
Excellent.
My experiment camera. Like Joe, I'm also presenting from home today. So I've commandeered the kitchen table and I've set up an experiment camera over here. So it gives you a better view of what you can see on my kitchen table. Now, a couple of materials that I thought we could use to try and demonstrate what a confirmation inquiry is a piece of card. So if you've got a piece of muesli box cardboard or birthday card or something similar, about 10 by 10 centimeters, doesn't have to be exact. So any cup will do, and a coin, or in this case, I've got a washer. And I'm just going to place that card on top of the cup, and I'm going to place the coin on top of the card. Now, let's say, for example, you may have just taught, Newton's first law of motion. So you may have taught students that something that is still is going to stay still unless another force acts on it. Or in that same respect, something that's moving will keep moving unless another force acts on it. So you may be able to see, I can see Jefferson, you can't see at the moment.
So what we're doing at the moment, everyone, is Jesse's changed to a camera that is just going to look at his desk so that you can see the experiment as he does it. If, when you look at your screen, it's quite small, what you should be able to do is click on the side of the video and drag it to make it larger.
Thanks, Joe.
Not to worry, Jesse, carry on, mate.
No worries at all. So confirmation inquiry, let's say that you've just taught Newton's first law of motion and you're trying to confirm for the students, or get the students to confirm that concept. Then you might set up a small structured inquiry like this. And something that lends itself really well is a strategy that was developed by White and Gunston called predict, observe, explain. So that students, before doing the activity, you would explain what you're going to do. So I'm actually going to flick this card out of the way very, very quickly. And then you might ask the students to predict what they think is going to happen. So if you'd like to participate, maybe you've got the materials at home, or if you don't have the materials at home, pop in the chat, what do you think might happen when I flick this card out of the way very, very quickly? What do you think might happen? So that's the first stage of predict, observe, explain. It's really great for physics and chemistry because we're able to observe these phenomena very, very quickly. Doesn't lend itself so well to biology because some biology concepts takes a while to see an effect, but works particularly well for physics concepts. So if we were to flick this card out of the way, the next step would be to ask our students to observe what they see. So I'm going to flick this card out of the way very, very quickly and take notice of what happens. Then we might ask our students to record what they observe. So if you'd like to record what you observed, pop it in the chat. I'm seeing some great predictions in there. So this is something that you might do after you've taught the concept, because after the students have observed, you may ask them to explain what they've seen. Joe, if you could flip back to the other camera, that'd be fantastic. Thank you. So they're really easy to set up and they're quick. But a mentor teacher of mine actually told me it's the equivalent of giving away the butt of a joke before you've set up the joke. So quite often it's more powerful if you're doing a small structured inquiry where you're not giving the students the answer to what is going to happen. This is really useful in that sense for formative assessment. So you're able to quickly find out across your students, what are they thinking? What are they thinking about before you dive into an inquiry like this? And in that way, it's pretty similar to the types of demonstrations that you may have seen last time when Graham was doing his demonstrations. He didn't immediately give away what was going to happen, but let the students figure it out for themselves. And absolutely, I can see that Louis is responding and saying that it elicits more organic answers from the students, and that's totally right. So it's probably a weaker form of inquiry, but it is still pretty useful if you want a quick, snappy way of confirming a phenomenon that you see in class. So if you wanted to do it again, there's no reason why you couldn't set up that activity, but not give those students the answer. So moving on, I'd like to talk about that next level of inquiry, where the student's given the question and they're given the procedure, but they're not necessarily given the answer. I'm just checking, Joe, which screen is currently spotlighted?
At the moment, we don't have any of them spotlighted so that we can see your shared screen.
Beautiful.
And that'll be bigger for everyone. And then when you want to go to the table, you let me know and I'll spotlight that one.
No,
if you like.
Thanks so much, Joe. So structured inquiry is really useful and efficient for a whole group, and it helps students develop inquiry skills in a more scaffolded way. And something that I like to do to help students sort of document their inquiry is using a graphic organizer, like a KWL. So you may be familiar with KWL charts already, and over time people have added all sorts of different columns to these charts. But I'm going to bring up an example of one that I might use for a structured inquiry. So the question that we might be exploring, or that we're going to explore in a minute, is related to heat. And so if you want to participate in the activity that we're about to do, have yourself a heat-proof cup, a metal spoon, a plastic spoon, and a wooden stick. Now, we're going to explore a bit of conduction, so how heat moves through solid objects. But before I would do something like this with students, I might do a chart like this to try and tease out what they already know about the subject and give them a bit more agency over the inquiry. I thought we could do one together right now. So I'm going to share with you a link in the chat to a group chart that we can fill out for columns 1 and 2. So we're going to ask, what do we know about conduction already, or what we think we know about conductors, and what we're planning on learning, or what do we want to learn about conductors. And I'm just going to get that link and pop it in the chat to everyone now. So have a go at filling in columns 1 and 2 in that link. What do we think we know about conductors? And what do we want to learn about conductors? And then we're a couple of
Jesse, everyone should be able to, sorry, I was just going to say, Jesse, everyone should be able to click on that link and it'll open up in a new scene or in a new window, and then they should be able to add their own thoughts and their name will appear. Beautiful.
That's right. And so if you're unable to access that, you should be able to see that on screen too. So again, this is a really nice way of trying to find out what your students already know about a subject. And it's great for formative assessment in that sense. And so you've got a record of what they know. Oh, that's a great question. Aside from metals, what other conductors can be used in households? And these are the types of things that your students might come up with as well. So while we're filling that in, Joe, do you want to switch over to the other camera? If you've got some hot water available, be mindful that if you're using water near your device, not to get it on your device. But I've also got some butter here. I'm going to take the butter. Now you might have coconut oil, or you might have petroleum jelly, or something else that is going to be solid at room temperature, but melts when exposed to heat. Now this uses stuff that you might have lying around in the kitchen at home. It has stuff that you might have lying around in the classroom. But what I'm going to do is I'm going to take a small amount of butter, and we're going to explore the question, which materials are good conductors? So we're going to compare these three things. I've got a little bit of butter on my wooden stick, my popsicle stick. I've got a little bit of butter on my plastic spoon, and a small amount of butter on my metal spoon. And what we're going to do is observe what happens when I place some hot water. Now that's a little bit tricky to see, so I'm just going to pop a box underneath there so you can see very clearly what happens to the butter. Now at this point, this might be where you would ask your students to make a prediction about what they think is going to happen. I'm going to pour some hot water in my cup. And I'll leave that set up there for the time being. I'm going to switch back over to, so thanks to everyone who've answered some of those, answered those columns. I'm going to switch back over to the presentation and we'll continue having a chat. So over time, we would expect something to happen to the three different materials. Now, you may have already asked your students what they predict is going to happen, and they may have predicted that one of those is going to melt the butter quicker than the other ones. Now, once you've done this, you can then revisit that chart and complete the other two columns. Now, because we're on a bit of a schedule here, I do have a video that I can show you as well of what we might expect happens. So heat can travel through solid things. That's what we knew. And we were exploring which materials are good conductors. So here's a small video about what we could expect happen. Now I've sped this video up and you may be able to see that something changes. So this is where we would get our students to observe and record. And if you ever have to teach online for whatever reason, I find videos are a really neat way to bring something into the class or into the virtual classroom that you might not always be able to do with your students. And you can film these. I just filmed this one on a smartphone. We're going to go to the next slide. So after we've observed what happened, pop in the chat, what did you notice happened to the butter? And if you have a look at the experiment cam on screen, you'll notice that something similar has happened to the cup that we had underneath the experiment camera. We can see that the butter has melted. We may be able to see that the butter has melted on the metal spoon, followed by the plastic spoon. What did you see happen, either in the video or on the experiment camera? Yeah, that's right. The butter has melted quite easily on that metal spoon too, and very quickly. So afterwards, we can revisit that chart and complete the other two columns. So if you still have the Padlet open, which was the chart that was online, I'm going to pop the link back in there. Oh, thanks, Joe. Jump on there and pop in what you thought after completing that small structured inquiry. What did we learn? You can see Jade's put down that the best conductor was metal. And a really great... What new questions do we have? Maybe you've got some new questions. Now that we know metal was the best conductor in that instance, what new questions do we have about conductors or how heat travels through solid things? There are a number of ways that we can complete these sorts of charts, and there are a number of versions of these sorts of charts, and there's no one right way. So there are additional columns that you can include. Has anyone ever used one of these charts before? Pop in the chat if you've ever used one of these charts before. If you haven't, there are a number of ways that you can adapt it to make it your own. So a question that you might ask is, do all types of metal melt butter at the same rate? And I can see that those are the types of questions that we're getting on the Padlet, which I'm about to share with you now. So another question was, what types of plastics can be good conductors? Are all conductors made equal? These are new questions that you could explore with your students too. But as I said, there are a number of ways that we can adapt these charts to make them our own. So something that you might like to consider is, well, after we've asked what we want to learn, how do we find out? What do we have to do to find out the answer to that question? And that column might fit after what we want to learn. Or what action are we going to take? If it's a question that's related to something that the students could do to change their behaviour. Let's say you're exploring recycling in your school. What action could they take after they explore a question related to that? And a really important one as STEM educators, how do we know and what's our evidence for what we've learned? You can see on screen there that we know that metal's a good conductor because we were able to see that the butter was melted quickly on a spoon, on the metal spoon. But our students may simply pop down metal's a great conductor and leave it at that. So by scaffolding with another column there to ask them explicitly, well, how do we know that the metal was the best conductor? We can structure their inquiry even more. And something that I've seen other people do, which I haven't done myself, to be honest, but I've seen other people do this, and it's while the students are doing their inquiry, they write down the questions that they're thinking about at the time. And it can help prompt their thinking about where they're taking their inquiry. So thank you for that. I'm going to pop this hot water out of the way in preparation for the next activity. The next activity that we're going to explore is another example of a structured inquiry. But something to keep in mind is when we're doing these, what if the students arrive at something that we don't expect them to arrive at? What if the students end up with an answer to a question that conflicts with what the science is? A really powerful tool that we have as educators is questioning. And inquiry classrooms have a really high percentage of open-ended questions, the types of questions that you might ask your students that don't have a defined yes or no answer, or that don't have a clear-cut answer. Now, the types of questions that we ask when we're doing these inquiries, and this was explored by Kalwakar and Vijaypurkar in 2013, is that they progress as the students are doing an inquiry. So we start off by eliciting students' prior knowledge and then progressing through to directed questions that are going to encourage them to arrive at a particular concept. And a concept that I thought we could explore now through another structured inquiry are bird adaptations. Now, earlier we looked at a strategy, predict, observe, explain, which is really, really good for physics and chemistry concepts. But again, bringing biology into the classroom is a little bit more difficult because we can't always take our students out to observe the phenomenon that they might see. Now, the three birds that you can see on screen are relevant to where I live. Maybe you've got some birds that are relevant to where you live, but there are a kookaburra, which is up the top, a cockatoo on the left, and a wattle bird, which is on the right. So let's imagine that we're teaching our students a concept that some birds are better adapted to living in certain environments than other birds based on the shape of the beak that they have. Now, if you do have the materials available to do this activity, great. If not, we're going to do the activity together on screen. Now, while we're doing this activity, it'd be wonderful if you could have a think about the types of questions that you might ask your students to get them thinking about the concept of bird adaptations. If you've got any suggested questions that you could ask your students, pop them in the chat because we'd all love to hear them. I'd love to hear them too. So what I'm going to do is get my materials ready. If you've got a plate or a tray, if you've got a spoon, if you've got 30 small objects like 30 buttons or 30 marbles or 30 rocks, and a second bird beak type. So I'll go through those now. I'm going to bring my bird's habitat over to the experiment camera. So I'm using a large tray at the moment. And in my bird's habitat, which is just here, you can see that I've got a number of seeds. So rather than taking my students out, which would be wonderful, but not always possible, I'm going to try and bring a bit of biology into the classroom. And I'm going to try and tie in a bit of mathematics by recording the data with the students. And that, Louis, that's a great question that you could ask your students as well. So we've got 30 seeds in my habitat here, and I've got a couple of bird beaks. Now, the first bird beak that I'm going to compare is a spoon. This is our spoonbill. It's our bird beak number 1. The second bird beak that I'm going to compare, and you might be able to do this in the classroom with any number of materials. You could use pegs like this. You could use clips, for example, or in my case, I'm going to use some chopsticks and try not to embarrass myself using chopsticks, but that's okay. We're going to try and collect as many seeds as we possibly can using the first bird beak, and then we're going to repeat our experiment using the second type of bird beak. So let's imagine that these are two different birds and we want to find out which of these two birds is better adapted for living in this environment. As you can see, I'm giving you the procedure, which is typical of structured inquiry. I'm asking the question, which of these two bird beaks are going to be best? but I'm not giving the students the answer. The students can find out the answer for themselves. So Joe, if you wouldn't mind, I'm going to place a cup here. This is my bird's stomach. Giving me 20 seconds to collect as many as I can. I'd really appreciate that.
All right, Jesse, if you are ready, my friend, your time starts now.
All right, so I'm going to try and collect as many, whoop, I lost that one doesn't count, as I possibly can.
Halfway.
A pretty hungry bird.
And time's up.
Okay, I lost a couple there, but as you can see, I collected 5 out of 30. In that sense, I've collected some data, and your students will have collected some data too. When we repeat the experiment, pop these back in our bird's habitat, and your students could then use their second bird beak to try and collect as many as they possibly can. So Joe, if you wouldn't mind giving me another opportunity to redeem myself, that would be awesome.
Certainly, your time starts now.
I appreciate the encouragement, Louis. But
Time's up.
I'm going to be a pretty hungry bird this time round. Maybe I should have opted for this bird beak instead. But we have collected some data, and some of the questions that we could ask our students to draw their attention to what we've done. And Joe, if you wouldn't mind switching over the camera, we could ask them about the data that they've collected, and open-ended questions like, why do you think we collected more with beak number 1 versus beak number 2? So drawing their attention was another part that Kawakara and Merker talked about as that next stage of questioning. So after we've drawn out some prior knowledge of these students, we're then going to direct their attention to different parts of the activity. And at the end, try and direct their thinking towards the concept. So, well, why did we collect more with one beak than the other beak? Well, let's have a think. Why do you think we collected more with the spoon as opposed to the chopsticks? If you want to pop your answer in the chat, wonderful. If you want to have a chat, also great. Yeah, absolutely. So we can then link that back. As Louis said, the spoon's got a wider surface area. And so your students may say, wow, it's bigger. And we can tie that back into some birds that we may see in the real world, like pelicans with a huge beak for collecting food compared to, say, other birds. So thank you so much for participating in that activity if you were participating in that at home, and for offering such excellent suggestions. I'm going to switch over to guided inquiry now. And guided inquiry, I'm going to pop my bird's habitat out of the way, increases student agency even further. So in guided inquiry, learners are given the question. They're given the question, and the students themselves design the procedure for answering that question. It increases student agency, so they have ownership over their learning. And because they've got ownership over their learning, they're going to be more, well, we hope that they're going to be more motivated to learn about that concept. And provides students an opportunity to deviate from the procedures that we give them. Now, that can be pretty prescriptive as teachers. But sometimes it can also be a bit daunting. Both as a teacher, I know I found it really daunting to start giving that ownership over to my students, because then I didn't have control I felt as though I didn't have control in the class. But as soon as I settled into a role as a facilitator where I'm there to guide them, I found it much easier. But it didn't mean that I was completely hands off and all of a sudden not a part of the students' learning. But what I did was I gave them more tools to help them with their inquiry skills. And one of the tools I helped them with is using something called a controlled inquiry. And it sort of fits in between structured inquiry and guided inquiry. And it's something that Fitchman and Dana came up with. And Trevor McKenzie talks a lot about this in his books as well, if you're ever interested in exploring it further. But in a controlled inquiry, learners are given the question, but the teacher also outlines what resources the students have available. Because I certainly know that we don't want to set up our students for failure. So if we're able to give them the resources that they've got available and the limits that they have to answer that question, then it means that they're going to be able to be more confident to answer that question. It also means that from a practical point of view, you're going to have the resources to help them do that. Now, a controlled inquiry is also useful when, let me go back a step actually. If your students aren't quite ready for that, then something you could possibly do as a structured inquiry is actually give them the procedure, but jumble up the order of the procedure and have them organise the order of the procedure that's given to them. And that's a small stepping stone to help them on their way to guided inquiry. Alternatively, if they're not quite ready for guided inquiry, a structured inquiry is a pretty useful way of doing that. And I'd love to talk about an example that I did with a group of grade 5 and 6 students in Melbourne, which was about earthquakes, which it could be, I know Graham talked last week about relevance. So in your part of the world, it may have a different relevance to the students in my part of the world. In Australia, we don't have a lot of earthquakes. They're not a common phenomenon. And so our students were really interested in finding out more about them. And this type of guided inquiry, where they were designing their own procedure for answering this question, which types of buildings are best for withstanding earthquakes, I used something called the 5E model. And the 5E model, it was developed many, many years ago in 1987 by the Biological Sciences Curriculum Study. And it can be used over a single lesson, and it can be used over many, many lessons. You may be already familiar with the 5E model. And when I did use the 5E model, I used controlled inquiry as a means to set up a guided inquiry later on with the students, or a more guided inquiry, which was less prescriptive. So to begin with, where I engaged the students, I used a balloon earthquake hook, and it served two purposes. The first purpose was to get students thinking about a phenomenon that they weren't familiar with, which were earthquakes. So at this stage, we didn't tell the students what we were going to learn about immediately, but we did do a POE, a predict, observe, explain, which was that small confirmation inquiry, but in a structured way. So we didn't tell them what would happen when they stood on the table, but we got them to predict how many students we could fit on the table with those balloons underneath.
Yeah, Jesse, I was just going to say, can you explain what the balloon earthquake scenario is and how you set that up?
Yeah, so this is it's loads of fun. The kids really enjoy it. We get a table and we turn the table upside down and we place balloons underneath that table. And then, and the balloons that we place under there are about 6 or 7, depending on how many and how big they are. But we didn't blow them up all the way. We only blew them up a part of the way. So they're still a little bit stretchy. And then we asked the students to predict how many we could fit of them on the table, which tied into the second purpose for this activity, which was to get them thinking about building design and weight distribution. So how weight is spread over an area or over a surface area. So after doing this activity, we then went into the next phase. But the students absolutely, they really like this one, and I'd highly recommend it if you do get an opportunity to do that. So we were able to hook them into the topic that way. Then we started to explore through that controlled inquiry. So the question that we asked was a little bit more narrow. We had a look at some buildings and what features those buildings had to keep them standing upright. And a lot of the students noticed that these buildings have columns, or they're supported in different ways. And so we did a controlled inquiry together where we made different shaped columns, and the students investigated which shaped column was strongest. So they were given the question, which shaped column is strongest? And using just some pieces of paper and some tape, they were able to create a procedure for making these columns, or testing these columns rather. But again, it's very easy to go away and say to students, off you go and find out which column's strongest. If they don't have the support to do that, it can be quite daunting for them, and it can make our jobs as teachers a little bit more tricky too. So something that I particularly like to use is a strategy called Cows Move Softly. And Cows Move Softly introduces the idea of dependent, independent, and controlled variables in a really gentle way. So when students were designing their own investigation, what were they going to change? What were they going to measure and observe? And what were they going to keep the same so that the answer that they got answered the question that they were asking? And I'll give you an example now. And if you do have a piece of paper handy and you'd like to participate in this activity, I'd love you to join me. Joe, if you wouldn't mind switching over to the other camera.
I can certainly do that. And I will say this is probably my most favourite experiment of all time. And I know some people, particularly Jade, who is also watching, knows how much I love this demonstration. Jesse, it just looks like your video has stopped on the overhead camera.
Oh, alrighty then. I'm going to investigate that myself right now. I'm going to turn that one back on.
As you sort that out, I was just going to say, this is also an experiment that can be used in a whole range of different settings. And it sort of highlights the fact that whilst you might learn a concept or an approach in one setting, it really can be applied to a range of others, which I think is the beauty of a whole bunch of the things that we're exploring. Now we can see that camera. Excellent. Thank you, Jesse.
No, thank you. So using a piece of paper, if you've got a piece of paper handy, let's have a think about what, for starters, what if we were to make these columns, we know we're changing the shape of the columns. What can we measure once we've made these columns? Pop in the chat, what do you think we could measure once we change these columns? We're trying to find out how strong they are. Thanks for popping that in the chat, Joe. So what could we measure? If you want to make some columns, if you're at home, and oop, we good? If you've got some a piece of paper at home and you want to make the columns with me, you can follow along on screen. So fold your piece of paper in half, and then fold your piece of paper in half again. Yeah, that's right, Louis. We're going to test how much weight they could hold. And that's a question that I ask my students too. So I'm going to now, once I've folded my piece of paper in half, I've got 4 even strips that I'm going to chop out. So once you've ended up with 4 even strips, now you can decide whether you're going to test a circle column or a square column. We'll leave it with 2 for today's workshop, but a circle column or a square column. If you want to make a circle column, simply take your piece of paper, roll it up so that there's a small overlap, and then using a piece of tape, you can place that on where that overlap is, so you end up with a circle column. And you can repeat this with those other 4 strips of paper. Maybe though you want to make a square column. So if you'd like to make a square column, fold your piece of paper over so that there's a small strip, so it doesn't quite reach the end. That's a little bit hard to see there, but it's not quite meeting the end. And then fold your piece of paper over again. Up to the point where we folded it earlier. See how I still have that piece on the end there? I'm going to then fold that piece over the top. Then I'm going to unfold my piece of paper. Take that small flap that I made earlier and fold it over that open edge. I'm going to pop a piece of tape there. Once I've done that, I'm going to make my creases a bit neater than I have previously. And I should end up with a nice square column. Now, again, don't worry, if you don't have this at home, I'm going to test this out with us together right now. Once you've got 4 of these columns, let's start with our square columns. If you were doing this activity with your students, what are some things that you might get them to consider keeping the same? If we wanted to compare 2 different types of columns, let's say, would it be fair if this column was taller, for example, than this column? That's right, Louis. The weight for all of the columns should be the same too. That's exactly right. So, and that's that keep everything the same part of Cows Move Softly. They're the variables that we're trying to control. Now, I do have some weights here, but so you're able to see more easily on either camera, I'm going to tilt my camera down now and I'm going to start placing some weight on. Now, if you're doing this at home, you might be able to use some books. And I've tried to find as many books as I had that were a similar weight. And I'm going to try and place these on top. If you would like to, pop in the chat how many books you think we can fit on these square columns. Make a prediction. How many of these books do you think we could? This is a pretty chunky one. I've done this a couple, 4 to 6. They are going to be pretty heavy. We'll see how successful we are. 3 books, all right, let's observe what happens. So I've got 2. 3. If you haven't figured out, I do like birds. 4. 5. Now I am cheating a little bit here because my books are different weights, but I've used what I've had available. What would be important though, what do you think actually might be important when I do this again with the circle columns? I'm going to put another book on there. 6. 7. Yeah, thanks, Louis. Yeah, I'm going to use the same books next time. 1, 2, 3, 4, 5, 6, 7. 8. 9. Oh, there we go. We were able to get 8 comfortably, and we've been left with some pretty squished columns. But this time, let's use our circle columns. And we're going to do this again, and I'm going to use the same books in the same order. All right, let's see how we go. How many do you think we'll get this time? Jade thinks we're going to get 4. Think we're going to get more. Angel thinks we're going to get 6. All right, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to use my last book. We'll see if this supports my last book. There we go. How many did we get that time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 books we were able to support. Now, I would keep going, but I've run out of books, so I'm going to move these out of the way. And now, you might have a chat with your students about why that was the case. Now, in our instance, we linked it back to the first activity that we did together. So in the guided inquiry that we were doing, we linked it back to that earthquake activity with the balloons, and we talked about the distribution of weight. And so that first activity was an anchoring event. It was an event that we were able to refer back to later on to try and reinforce that concept. But that was a gentle way of introducing how they could set up their own procedures for trying to explore that question. And that question of which column was stronger, the squares versus the circles, was more narrow than that bigger guided inquiry question of which types of buildings are best for withstanding earthquakes. So in this explain phase of that inquiry, that's what we talked about. We also linked it back to some examples from the real world. So that picture there is the cardboard cathedral in Christchurch that was set up after the Christchurch earthquake. And that uses cardboard tubes in a similar fashion to, say, our paper columns. So this is where the students then elaborated on what they are learning through another inquiry. And it was a different activity where they actually built small cardboard structures and tested them to withstand a mini earthquake. So they set up an earthquake tray, very similar to what we had earlier. So they had their tray. And Joe, if you could switch over to the other camera, I'll show everyone what our tray looked like. It's really basic. It was just a tray with marbles in it, and they placed a piece of cardboard on top. And they moved that piece of cardboard on top of those marbles with their structures on top, the structures that they had built, and they were able to test how long it took their structures to fall. But thinking back to Cows Moo Softly, we had a discussion about the things that they keep the same. So when they were using their earthquake testers, what are some things that they might have to consider when they were keeping them the same? Or what are some things that they would need to keep the same? We did have a discussion about the strength of the machine and how strong they would move their machine around. So how hard were they pushing left to right? And to try and answer that question, together we built a seismograph. And so we actually placed that on top of the machine and linked it back to something that people who study earthquakes, that's right, the earthquake's force, how strong is the earthquake? We built this seismograph using some paper, just a cardboard box. We placed this on top of the machine, and if you can see in there, it's a cup with some rocks in it, which is suspended from a pencil. and there's a pen sticking through it. And so as the students were moving around to calibrate their machine and find out how strong each student was pushing it to make sure they had consistent results, another student pulled this piece of paper through the seismograph, and they ended up with some visual data that they could use to figure out how strong their earthquake was. And Joe, I can send through the instructions for how to build one of those and maybe able to share them through the Facebook page.
Certainly, that would be brilliant, Jesse. We'll put all those resources up. We've had lots of people asking if they can get access to the slides and the other information, so I will make sure it's available to everyone.
Fantastic. And I'd love to see any sort of pictures. If you do use any of the activities, I'd love to see some pictures of you using these. So at the end of the guided inquiry, where students had then created their own procedures for trying to test which of their buildings were stronger, they then went back and did one of those charts. So what have they learned? How did they know? What action were they going to take? And what new questions did they have? And then they communicated their findings, which is a really important part of the inquiry process. And it helps them to consolidate their thinking, which is part of that evaluation phase. Now, to finish up, I just wanted to finish on open inquiry because it's kind of that last frontier in terms of inquiry, where the learner's developing the question and the procedure. And it's something that really takes a lot of time to develop those skills with students, which is why I tend to use a lot of guided inquiry and structured inquiry. And even with older students, it was quite tricky to develop open inquiry. Not impossible, but it is something that you want to make sure that you've built up those skills with your students before diving into an open inquiry. The most beautiful thing about open inquiry, though, is that students are really passionate about it because they're developing the questions that they want to explore. And it's really well done in consultation with the teacher. So when you're thinking about or going down this route and getting students to develop their own questions, ask them to consider what are they interested in, because that's going to help that inquiry process. If they're exploring something that they're interested in, they're going to invest a lot of time in it. Make sure it's something that they don't already know the answer to, because there's lots of examples, I'm sure, of students who think, great, I'm going to answer a question that I already know and get an A for this subject. And make sure that the questions that they're asking have a clear focus and a narrow. In the previous question, that which buildings are best for withstanding earthquakes, it's a pretty broad question. But when we were exploring the columns, the question was more narrow. And it's totally okay to have questions that are more narrow within a bigger guided inquiry that answers a sort of broader question. And that brings me to the end. So I've been so fortunate to join you all, and thank you so much and for sharing your responses and joining me today. And thank you to Joe and Science Circus International. It's been a pleasure.
Can everyone join me, even if it's just a virtual hand clap, but a huge thank you to Jesse. It's really nice to have his expertise and have his time to be able to share some of his lessons. One thing that I will say is, well, first of all, massive thank you to Jesse. It's been brilliant. And I love that you finish on open inquiry and really highlight that is an area that is, as you say, the next frontier in terms of inquiry learning. And the session that we're going to be holding next towards the end of April is actually going to be all around tinkering, which is very much on that open-ended side of the inquiry spectrum, and is a great next step, thanks to where you've left us today. All right, everyone. There's a few things that I wanted to touch on before we finish up. I'm going to put some things into the chat that I want everyone to take note of. The first one is to make sure you're on our mailing list, because a bunch of our teachers and educators that have been part of this have been amazing and have been sharing the word and making sure their colleagues are aware of these sessions. The downside to that is we don't have some people's emails, which is really hard if we want to send them surveys or make sure they can get certificates. So the first thing I'm going to do is make my face come up in the screen. 1 second, everyone. Okay. Beautiful. You should be able to, can everyone see my face? Jesse, can you see my face as the main face? Excellent. Okay. So the first thing I'm going to put up is the link to make sure you are on our mailing list. And it goes like this. So if you aren't already getting emails from me, if you click on that link, you will be able to ensure that you stay up to date with when the next workshop is and get that Zoom link. As I say, the next session is most likely going to be towards the end of April, in about 2 weeks' time. We're finalising some details because we're bringing in an expert from the United States, and they're just moving over to Germany. So it's sort of a very international crossover, someone from the Northern Hemisphere with quite a bit of experience in this area. The next thing that I want to share with you is a few various links to some of the resources or ways you can engage with us. So there should be a whole bunch of things that come through now. That first one is, if you do have questions about our experimental design and some of the work that we're doing behind the scenes with the data that we're collecting, you click that first link. If you want to follow us on Facebook, as I say, the big open community of everyone that's experienced or interacted with Science Circus International, you click that second link. Because you have been part of some of our workshops, we are now opening up the opportunity for you to join our closed Facebook group, which is just the people that have taken part in these workshops and other things we've done all around the world. It's that next level of engagement with people that have tested our approaches, and it's a great resource for talking to like-minded teachers, educators, and communicators from across the world. The final one there is the YouTube channel. So that is where we put all our videos of our workshops once they have been uploaded. And this one, tomorrow morning, most likely, given how big the recording is going to be, it'll be uploaded and I will send you out a link to make sure you can access it. Now, the absolute final thing is that everyone has been asking about certificates and can they get a certificate for a session that they haven't seen live? And the answer is yes. When I send out an email tomorrow, we'll have links to the previous workshops and their associated surveys. If you watch that workshop and complete that survey, you will then have the ability to download your certificate. And the final thing that I'm putting in right now is a link to today's survey from this workshop. So if you fill that in, the final thing you will get will be your certificate. And really, we're trying to design this so that each session builds on another. And by the end of it, we can have a whole bank of knowledge from everyone that's participated. I'd also love, those surveys are an opportunity for you to share your insights. Because I said this at the start of the last workshop, and because we have so many people from across the world, I don't know the right word, but invariably there is a phrase for the white foreigner. I know in Fiji and Samoa, it's Palangi, Kavalangi. It's important for myself and for Jesse and the rest of the Science Circus International team to acknowledge that the majority of us are white males with a certain experience of the world. So we don't want to come in and just tell you one way of doing everything and pretend that it's the right way. What we're trying to do is share some of our insights, and we also really want to learn from you. So if there are things in these workshops that you think that would work in your setting, but it will be much different for me where I have to teach, we want to learn about those things so that we can get better at what we do, and we can share the things that you've learned with the various people across the world that we interact with. All right, everyone. Jesse, do you have anything else to add before I send everyone on their way?
No, Joe, I think you've covered that. It would be wonderful to hear all about how you could apply these, and maybe how you couldn't apply them. So like you say, Joe, I can equally learn.
Beautiful. And for those people that have been asking as well, all the resources, the slides and the information on the seismograph, and the links to the information about confirmation inquiry, structured inquiry, guided inquiry, and open inquiry that Jesse has shared with us, I will make all that available to you, and it will come through all the channels that you will now have access to. So if you miss it in one, you are guaranteed to get it in another. Beautiful. All right then. Thank you everyone for your time. I'm going to stay on the line for a couple more minutes. If anyone has any questions or any comments that they want to share with me, please feel free to do so. Jesse, thank you again for your time, and I'll be in touch to do the wrap up later on. But thank you everyone, and have a fantastic lunch, morning, afternoon, evening, night time.